All right, so let me try again. Had more trouble than usual installing Go this time, but all right. So let me summarize how we got here for people who are starting from the beginning. We start at samsclass.info and then go to Go the Wrong Way. And once you have a Linux server, we're here on A51, basic port scanning in Go. And the version is now 16.6, so you have to adjust the download command by changing the numbers here. The URL to download it is different than the URL that appears on this Go page, so you have to really just change the version numbers in this command instead of copying and pasting that URL. And then you'll get the right hash value. And when you install it here, again, you have to adjust the version numbers. And students found that the new version of Go requires this goenv command to compile. So I added it to the instructions. And when you're done, you can finally make a Hello World program. Now, Go is a modern programming language, and by default, when you compile, it doesn't compile just one file of source code. It expects you to have a folder where you're going to have several modules that are being combined. And so the cycle that I got used to is this: every time you make a new program, you make a folder for it called My Project, and then you so you create this folder called Hello, and then you put your code in this subfolder, hello.go. Then you can put in some code and compile it with go install. So I've got that here. All right, so if I should have a nano command back here. There we are. So it's this crazy path, my project hello.go, and this is my Go source code. So you import the format package, and then you can do a format print. And this gets you to Hello World. And when you compile it with go install, my project hello, I have to spell go correctly. All right, and now you can just type hello, and you see Hello World. So now I can get down to making the port scanner, and I see some students saying there's some unexpected results with the port scanner, so let's see what happens there. So you make a directory for the port scanner and create a file for it. All right, and now this uses more packages, net and string convert. All right, and why is my nano not working? Control X. Let's try that again. All right, good. All right, so this is going to be a loop going through 65,000 ports, and it's going to scan your local machine, which is probably why people are getting unexpected results, because you're scanning your local machine, and the number of ports open on your local machine will vary. So you may not get exactly my answer. So now I install it and run port scan, and it will tell you what ports are open on this machine. And on my machine, I have several ports open, but on your machine, people are saying 22 and 631. That is expected. 22 is the SSH you're using, and 631 is a printer sharing port. That's what's on a default Debian install. And if you install more software, more other things might be open. So this is fine. The exact ports you see will vary, but you'll always see 22 if you're connecting with SSH. That must be open. So that's fine. So this scanned all ports on your local machine, so it runs really fast. And then we'll make a banner grabber, which is this one here. So that's going to be port scan 2. And that's here. And you may recognize this is pretty much the same stuff we did with Python the first day. So I would make this bigger if I could get my hands on it. There we are. And now up. All right, so it's the same, except now I'm only going from ports 20 to 25. I don't want to try to scan 65,000 ports of a real server over the internet. and this is one of the target machines you've used before. So it's going to try those ports on this machine, and it's going to do the error handling. If the error is nil, if there was no error, then it will tell you the port is open. Otherwise, it'll skip that port and not have a message, so it won't freeze on the first error the way our port scanner did in Python. So I install that one and run it, and now it finds 22 is open, but the other ports are not open, which is to be expected of a normal server just running port 22. And now you can make a third one that will scan more ports. All right. And the same old install and port scan 3, and this one will go from 20 to 30. That's all it does. All right, and there it goes. And when it hits 24, it freezes because it hits 25, and 25 is SMTP. And SMTP, like HTTP that we did before, is open, but it does not have a banner. So this port scanner can't move forward because it's missing a timeout. So we have to add the timeout to the port scanner, and that's here. And there we go. Now I had to import a fourth library called time. And this will go from port 20 to port 30, and it has a timeout someplace in here. Yep, set dial timeout. Dial timeout TCP time.second and 1.time.second. So it will time out after 1 second. Now let's do this one. All right, and now it hits 25 and only pauses for a second before continuing with an IO timeout. So now you have the ability to scan ports and fetch banners. So now you can, there's a flag there, and then there's more things to find here, and you may recognize quite a few of these are the same thing you did with Python a few days ago. There's a banner defined on this port, and there's the port knocking, and here's how you split a string in Go, and so on. So there's a few challenges here where you can practice writing Go to do these things. I'm going to stop recording.